Okay, this video is to help you with exercise 15, problem 90. And in this problem, we're asked to calculate Ksp. Ksp is for when you have insoluble products, when you have a precipitate, the formation of a precipitate. And this is directed towards equilibrium reaction. Okay, because you're going to have some free ions and you're going to have a lot of precipitate. Okay, so we have this representation called Ksp. This is the equilibrium constant for solubility product, Ksp. Okay, so as you're approaching these problems, we'll go ahead and work with our cadmium sulfide first. Okay, first thing you want to do is you want to write down your chemical equilibrium equation. So you have your precipitate in equilibrium with the free ions. There's very, very little free ions. It's dependent on the Ksp, but there's still a little bit of free ions. But majority of it is precipitate. Okay, so we have cadmium ion. Don't forget to have the proper charge, and sulfide ion. In your equilibrium expression for Ksp, you're not going to include anything that is a solid. Okay, so you're going to cross out the solid. So essentially your Ksp will equal the concentrations of your cadmium and your sulfide multiplied, the product of your concentrations of cadmium ion and sulfide ion. Okay, and we're given those concentrations. And it's 3.7 times 10 to negative 15 molar for the cadmium and 3.7 times 10 to negative 15 molar for the sulfide. You multiply that, and your Ksp is 1.37 times 10 to the negative 29. Ksp is an equilibrium constant. Equilibrium constants have no units. Even though you may be tempted to put meter square and molar square, equilibrium constants do not have units, so keep it unitless. I went ahead and gave you a couple hints for the next two problems and wrote out the equilibrium equations for barium fluoride and silver sulfate. What's important in these two is if you look at the coefficients. Okay, so the coefficient becomes an exponent. So you're going to raise your fluoride to the second power, and you're going to raise your silver to the second power. Your coefficients become exponents. Okay, so this is how you solve for your Ksp in this problem.